everybody. Hi, welcome to Momentum with Vedantu. Welcome to our next episode today. We are going to be studying today refraction at spherical surface, guys. Okay, we are going to be studying refraction at spherical surface. I think Sri Balaji, Kaushik, Surinder, Jas, and Pranati, all of you are here. Superb, Kaushik. Hi, Kaushik. Kaushik is the first one to give the answer. Huh? Very good, Kaushik. Superb, superb, superb. Okay, so so nice to have all of you here, guys. And today, we are going to start refraction at spherical surface. Okay, hi Priyanka Sunday. Hi. Okay, so before we start, guys, before we start, a very quick refraction and spherical surface is what we are going to study. Okay, hi Fab Phoenix. Okay, Saurabh. Oh, Saurabh is also in class 12th. Okay, guys, super. So, guys, let's talk about refraction and spherical surface. But okay, I have an important announcement, but I will make that in between the class. Okay, please remind me to make it in between the class. First, let's talk about last time's the guy who gave the first answer. That is Arlen Kaushik and Entertainment 2015, who was 41 seconds late. Huh? Entertainment 2015, it's okay, Entertainment. Next time. Okay, your name also came today. No issues. But next time, everybody's name is came. And Kaushik, I hope you got the notes. I think you got the notes, Kaushik. I hope so. Can you tell me if you got a note? Can you tell me? Hmm. Hi, Nikhil. Okay. I hope you guys got the notes. Okay. I have shared the PDF files. You should get the notes. Okay. All right. So next, what we do, guys? Next, what we do today, we are going to start a refraction at curved surfaces. Okay, refraction at curved surfaces. We are going to talk about multiple refractions and all those things. Okay, Today is where things start getting a little bit difficult. Okay, up until now it was bachcho wala padhai. So let's do this. Okay, what exactly is refraction at spherical surface, guys? What exactly is this? So let's say I have an object here. Okay, and I want to find out where the image is going to be. If I have a I have a curved refracting surface here. Okay, let's say on one side the medium has refractive index n1, and on the other side I have a medium of refractive index n2. I want to find out where the image will be, at what distance it will be. If this is the object distance and the image distance, what will be the relation between the two? How does R come into the picture? I want to know all those things. Okay, Saurabh, thermodynamics is going to start from tomorrow. Okay, so guys, how do we go about it? So first of all, let's assume that I just have this picture. Okay, I just have a curved spherical surface like this, and I have a center of curvature and two mediums n1 and n2. Okay, and now let's say I put an object on this line. By the way, this line is called principal axis. Okay, so right now, just for simplicity, let's keep an object on the principal axis like this, and I want to know where the image of this object will be. So guys, in general, whenever we want to find out image, what do we do? We take out two incident rays from the object. Okay, how many? Two. So what we'll do is we take out two incident rays from the object. Okay. Shri Balaji, today's refraction is spherical surface. Next time we'll start lens, and this chapter will be the over soon. Okay. So this is the object. Two incident rays are coming out of the object. Now I will see where do they go after the refraction. Now I will see where they will go after the refraction. Now guys, if you look at this ray is incident normal to the surface. Okay, this ray is incident normal to the surface. So where do you think it will go after refraction? Where do you think it will go after refraction? Straight. Very simple. Okay, angle of incidence is 0. Angle of refraction will also be 0. I hope everybody understood. Hi Tirupati. Hi. Okay. So, what about the second ray? Where will that ray go after refraction? In order to understand where that goes, what I will need to do is I will need to make the normal at that point. So normal at that point. This normal, by the way, is supposed to be perpendicular to the surface at this point. This angle is 90 degrees. Such that I have to make a normal like this. And of course, if it's a spherical surface, then the normal has to pass through the center of that spherical surface. This center, by the way, is called center of curvature. I hope everybody knows so far. Okay. Now next, if I know that this is the normal, what will be the angle of incidence? This will be the angle of incidence, the angle made with the normal. And now that I know angle of incidence, I can use something called Snell's law. Okay, using Snell's law, I can write n1 sine I is equal to n2 sine r. If I know the value of I, if I know the value of n1 and n2, I can find out the value of r using this equation. Now that I know the value of R, I can make the refracted ray. I can make the refracted ray. Okay, where this angle will be the angle of refraction. This angle will be the angle of refraction. It's the angle made with the normal one. Okay, now if you see here, guys, if you see here, this is the refracted ray and this is the refracted ray, and both of them are meeting at this point. Both these refracted ray are meeting at this point. So that point will be what? That point will be what? That point will be the image in this case. That point will be the image in this case. I hope everybody is following. By the way, in this case, what type of an image is this? Is this a real image or a virtual image? Can you guys tell me what type of an image is this? This is a real image. Okay, because the rays are actually meeting at that. The rays are actually meeting at that. Okay. So this is how image formation occurs in case of a spherical surface. This is how image formation occurs in case of a spherical surface. I hope so far everybody is with me. Guys, if you understood so far, please give me a thumbs up. If you understood so far, please give me a thumbs up. Okay? If you understood, give me a thumbs up, give me a thumbs up, give me a thumbs up. Everybody, everybody, everybody. Mhm. Mhm. Okay, I guess nobody understood, so that is okay. Yeah, that's Josh and Surinder understood. Two people understood. That's okay. That's okay. All right. So, if you understand so far, I will go forward, but before that, I have a very quick announcement. Okay, there has been a change in timings. Okay, so our normal lectures right now, the current timings are from 2 to 3. Okay, I have our normal 2021/22 lectures. Okay, and this 3:30 to 4. Okay, 3:30 to 4:30 or sometime. Okay, we have our revision lectures. Okay, so five advanced questions, whatever, whatever, whatever. So there is a change in the timings, guys. There is a change in the timings. This is the timings today. Okay, now from tomorrow, the timings are changing. If you are a 2021 or 2022 students, the timings for you is going to be, this is once again, let me write down tomorrow. Okay, the timings for you is going to be from 4 to 5. 4 to 5 p.m. And if you want to revise and do advanced questions and all that stuff, you have to come from 2 to 3. Okay, this is done. This is done on request of many of you. You wanted the times to be changed. So 2021 and 2022 lectures are going to be from 4 to 5 p.m. Okay, this was the important announcement, guys. I hope everybody understood. Okay, this is not just tomorrow, this is from tomorrow. So going ahead. Okay, and after a few days, we will close this batch, and we will after JEE Advance is over, we'll close this batch and we'll just focus mainly on 11th and 12th both. Okay, so one lecture for 11th, one lecture for 12th. That is how we will proceed. I hope everybody is with me so far. Okay, so now that we have a real image and object and everything cleared out here, Now let's talk about sign conventions in this case. Okay, if we are going to talk about the object distance, the image distance, and everything else, we need to know the sign conventions. Hi, Varun Shastri, for coming here for SAT tips, guys. If you have just joined me, I just announced 2 minutes ago. From tomorrow, our timings are going to be from 4 to 5 for the normal lectures. Okay, for revision lectures, it's going to be from 2 to 3. Okay, all right. So, hi Varun Shastri, I have not forgotten your SAT tips. It's coming, it's coming, it's coming. So, anyways, guys, let's talk about the sign conventions. Okay, here if we are going to talk about the object distance and the image distance and the radius of curvature, what do we take their signs as? We take their signs as positive or negative. What do we do? What do we do? What do we do? What do we do? Okay, so for that we have something called sign conventions. For that we have something called sign conventions. What are sign conventions, guys? Basically, sign conventions tell you what is the which quantity is going to be positive, which quantity is going to be negative. Okay, and this is a set of rules which is decided by everybody else in the world. Okay, so you have to follow what everybody else has decided. Okay, first is pole will be considered as origin. First is pole will be considered as origin. What does that mean? What does that mean? If you look at this diagram, this point is the pole and this point will be considered as origin. Whenever you are trying to measure any distance, you will measure those distance from this point. Okay, you will measure those distance from this point. Second, distances in the direction of incident ray will be positive and the distances opposite to the direction of incident ray will be negative. Okay, what does that mean, guys? What does that mean? If you look here, the incident ray is going in this direction, the incident ray is going in this direction. That means that this direction should be considered as positive. That means this direction will be considered as positive. Hey there, hi. Okay, next, if that direction is considered positive, now we can immediately talk about different signs of U, V, and R. Okay, so for first of all, let's talk about object distance. If you see, if you want to measure object distance, guys, if you want to measure object distance, what you need to do is you need to go from here to here. You need to go from here to here. And if you go from here to here, you have to start at origin, right? So you start at origin, go towards the object. You start at pole, you go towards the object, you're going in the negative direction, guys. That means object distance will be negative. That means object distance will be negative. Similarly, if you want to measure the image distance, then you have to go from here to here, guys. You have to start at the origin, which is pole, and go towards the image. Now, this time you are going in the positive direction. So, therefore, image distance will be positive. And similarly, if you have to calculate the radius of curvature, then in that case, you go from here to here. Okay, in which direction are you going? Positive or negative? You're going in positive direction. So R will also be positive. So R will also be positive. Okay, so this is how we determine the values as negative or positive. And this is the sign convention that everybody needs to follow. Okay, this is the sign convention that everybody needs to follow. Okay, I hope you guys understood. You are going in the positive direction, you are going in the negative direction. Now, by the way, who decides the positive direction? Who decides the positive direction? The incident ray decides the positive direction. Okay, incident ray decides the positive direction. If you had something weird like this, if you had something weird like this, like say this is the sir, this is the bow, this is N1 and N2. Okay, and let's say you have an object kept here. Let's say you have an object kept here. So in this case, wow, how will you calculate the object and the radius of curvature? Incident ray will go in this direction. Okay, and center of curvature, let's say, is somewhere here. So in this case, U will be negative and R will also be negative. U will be negative and R will also be negative. Okay, why am I saying that, guys? Why am I saying that? Because incident ray is traveling towards left. The direction towards left will be considered as positive. Okay, so in that case, your object distance will be negative and your radius of curvature will also be negative. Now, where the image will be, you can calculate later with a formula. Okay, you can calculate later with the formula. I hope everybody understood so far. I hope everybody understood so far. Now, next point is, guys, the heights above the principal axis are considered positive and heights below the principal axis are considered negative. Here I only have point object in this diagram, guys, but if I had a bigger object, okay, then the situation might have looked something like this. If I had an object big like this, then the image in that case would have looked something like this. Now if you see here, the object height will be considered as positive and the image height will be considered as negative. Hi Vulcan Darth Vader, hi. Okay, I hope everybody understood. Really hope everybody understood. Really hope everybody understood. Okay. Similarly, if you want more practice, just look at this diagram. Okay. If the light from the object is coming in this direction, then R will be positive. If the light from the object is coming in this direction, R will be negative. If the light of the object is coming from this direction, R will be negative. And if light is coming like this, if light is coming like this, R will be positive. Okay. You have to know where the R will be positive or where it will be negative based on the sign conventions. Okay, based on the sign conventions. I hope so far it's clear to everybody. Because if it is clear so far, then I can move on to the next point, and that is a relationship between U and V. Relationship between U and V. How do I calculate relationship between U and V, guys? How do I calculate relationship between U and V? Okay, U is object distance, V is image distance. So first of all, let's draw this diagram, and here let's mark some points. Let's say this point is equal to A and this point is equal to P, the pole, and this is the object, the center of curvature, and the image. These are all of my important points, and I also have Snell's law, N1 sine I is equal to N2 sine R. Okay. Now guys, here I am mostly going to talk about point size objects, or I'm going to talk about very small objects. Okay, here mostly I'm going to talk about point size objects or very small objects. So what I will say is that I and R are both going to be in general small angles. Okay, I and R are both going to be in general small angles. Why are they going to be small angles? Because I'm going to talk about small objects or point size objects. Okay, and the formula that we are deriving is also only valid for small angles. It's also only valid for small angles. I hope you guys understood. Okay, so okay, based on that, let's try to calculate the relation between U and V. In order to understand that, first of all, let's draw some three more angles. Okay, let's draw three more angles. Let's say these are the three angles, alpha, beta, and gamma. These are the three angles, alpha, beta, and gamma. Okay, and let's start our derivation from here. Let's start our derivation from here. Now guys, I don't know if you guys know this, but we have something called an exterior angles theorem. Okay, what does this exterior angle theorem say? What does this exterior angle theorem say? That if this angle is alpha and this angle is beta, then this angle is going to be alpha plus beta. Then this angle is going to be alpha plus beta. Okay, I hope you guys can see that. I hope you guys can see that. Here what I can write is I is equal to alpha plus beta. I is equal to alpha plus beta. I hope you guys understood. Okay, similarly guys, similarly I have once again an exterior angles theorem. Okay, what does this exterior angle theorem say? That if I have two angles alpha and beta, you know what, I'm going to use black color only. If I have two angles alpha and beta, sorry, if I have two angles, one second now, R and gamma, if I have two angles R and gamma, then if I extend this line, this will be the exterior angle, and that exterior angle will be gamma plus R. Okay, that exterior angle will be gamma plus R. So basically here what I can write, beta is equal to R plus gamma. Okay, or a better way of writing this is R is equal to beta minus gamma. R is equal to beta minus gamma. Beta minus gamma. R is equal to beta minus gamma. I hope everybody is following so far. I hope everybody is following so far. So now if you're following me so far, let's go to the next part. Okay, let's go to the next part. I know that I is equal to alpha plus beta and R is equal to beta minus gamma, and I also have something called Snell's law. I also have something called Snell's law. Okay, according to the Snell's law, guys, according to the Snell's law, what do I have? According to the Snell's law, n1 into sine I will be equal to n2 into sine R. N1 into sine I is equal to n2 into sine R. Okay, now since I and R are small angles, since I and R are small angles, okay, what I can say is that sine I will approximately be equal to I and sine R will approximately be equal to R. Okay, so using this guys, what I can simply write is, one second, what happened here? Why? गायब हो गई चीजें. Yeah, using this, what I can simply write is is n1 sine I, and n1 sine R will just become n1 into I is equal to n2 into R. N1 into I is equal to n2 into R. Okay, now once again, if you guys know, I and R can be written in terms of alpha and beta. I and R can be written in terms of alpha and beta. I can write n1 into alpha plus beta is equal to n2 into beta minus gamma. Okay, I hope everybody understood. I hope everybody understood. Guys, this is a very important derivation from NCRT point of view, so please pay close attention. Okay, now from this, very simply, you can do a little bit of rearrangement. You can do a little bit of rearrangement. Okay, if you do a little bit of rearrangement, guys, what will you get? If you do a little bit of rearrangement, what you get is n2 gamma plus n1 alpha is equal to n2 minus n1 into beta. N2 gamma plus N1 alpha is equal to N2 minus N1 into beta. Okay, I hope everybody understood. I have just opened this up and then rearranged. Okay, I have just opened this up, then rearranged. N2 gamma I took to the left side and N1 beta I took to the right side. Okay, so that is how we got onto this. That is how we came across this equation. Now, if I and R are small angles, if I and R are small angles, okay, then I can say that alpha, beta, and gamma are also going to be small angles. Alpha, beta, and gamma are also going to be small angles. Okay, in which case alpha can be written as tan alpha, beta can be written as tan beta, and gamma can be written as tan gamma. Gamma can be written as tan gamma. Jojo, derivations are also important now, my friend. Don't be lazy. Don't be lazy. Do the derivation. Okay, which I can substitute in the original equation. What was the original equation? N1 alpha, sorry, N2 gamma plus N1 alpha is equal to N2 minus N1 into beta. Okay, so substituting this here, I can write N2 into tan gamma plus N1 into tan alpha is equal to N2 minus N1 into tan beta. N2 into tan gamma plus N1 into tan alpha is equal to N2 minus N1 into tan beta. I hope you guys can see this. I really hope you guys can see this. Okay, now here is where, guys, here is where you have to pay a more closer attention. Okay, you have to pay more closer attention. If you look at this diagram, what I can do is I can drop a perpendicular here. I can drop a perpendicular here. Okay, and let's say this perpendicular, oh my god, my drawings are super good. Okay, let's say this perpendicular comes here at point N. This perpendicular comes here at point N. Okay, I hope everybody can see this. By the way, this point P and N are going to be very, very close, and that's why we can see them as very, very close, and they are confusing. But if you look at this, you can easily say tan alpha is equal to AN by ON. Do you see that? Do you see that? You can also say that tan beta is equal to AN divided by NC, and tan gamma is equal to AN by NI. Okay, I hope everybody understood. I really hope everybody understood. Now, guys, since N and P are very close, since N and P are very close, what I can do is yes, exactly, Fab Phoenix. There are very similar steps. Okay, Shri Balaji, why did we do that? Because we need a relation between you and we. Okay, we are deriving a relation between you and we. Okay, stay till the end and it will become clear. Okay, stay till the end and it will become clear. N and P are very, very close, guys. So what I can do is I can write this ON as just OP. I can just write this ON as OP approximately. Similarly, I can write this NC as just equal to PC. And finally, I can write this Ni as just equal to Pi. Ni as just equal to Pi. Okay, I hope everybody understood. Okay, now next is what do we do? We substitute all of this into the basic formula. Now, if I substitute all of this into the basic formula, guys, what do we get? Okay, we get N1 into AN divided by PI plus, sorry, not N1, N2, plus N1 into AN divided by OP is equal to N2 minus N1 into AN divided by PC. Okay, now that you know this, guys, now that you know this, you might see that some things here will get cancelled out. And AN will get cancelled out, which gives me my final very, very beautiful equation. What I get is, one second, what I get is I get N2 by Pi plus N1 by OP is equal to N2 minus N1 by PC. N2 minus N1 by PC. Jojo, sir, if I just attend your class, can I attend the questions easily? Because I find this isn't tough. So, Jojo, if you don't find this isn't tough, then go and try questions, my friend. If you find the questions tough, then come and tell me. I think you should go and try the questions. You might not find them very, very hard. Okay, now if you understand so far, guys, then let's look at this. What if I tell you what is the value of u? I will give you two options. Okay, I will say u is equal to plus op or u is equal to minus op. Tell me which one will you choose, guys. You have to tell me in the comments right now. Tell me which one will you choose. Tell me which one will you choose, guys. Everybody tell me. अरे कोई तो बता दो मेरे को चैट में. अरे री 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 री. Yeah, it will be the negative OP. Okay, it will be, I will choose negative OP. So you will be negative OP, V will be positive PI, and R will be positive PC. Okay, now another way of saying this is that OP will just be equal to negative U, PI will just be equal to positive V, and PC will just be equal to R. Okay, and that means I can substitute both all these three into my final equation. And when I substitute all of them into my final equation, what do I get? N2 by B plus N1 by minus U is equal to N2 by N1 minus R. Okay, N2 minus N1 by R. Or a better way to write this equation, guys, a better way to write this equation is N2 by V minus N1 by U is equal to N2 minus N1 by R is equal to N2 minus N1 by R. I hope, guys, everybody understood this question. I really hope everybody understood this question. Okay, if you did, please give me a thumbs up. If you did not, please give me a thumbs down. Okay, now if you found this easy, you will find the next question also very, very easy. Okay, that next question is very, very simple. We will solve it together in the class. The question after that is a little bit hard, but we'll solve that too. Okay, don't worry. Just solve this question first. Find out the position of the image formed and they draw the appropriate ray diagram. Draw the appropriate ray diagram. Okay, find out the position of the image and draw the appropriate ray diagram. Okay, they had given the value of u and v. I will delete that and you tell me. Okay. Yes, Shri Balaji, I will give the derivation of the formula in PDF. Okay, these notes will be shared. Don't worry, don't worry. Okay, the derivations I'm doing derivations because even though you don't need it for JEE mains, you do need it for two different things. You need it for your NCRT exams and you need it for your JEE advanced exams. Okay, because JEE advanced they will just you need to know the derivation if you need to know the concepts. Okay, otherwise you will get confused at some points. So for advanced, please know the derivation. You can't clear advanced without that. Okay. Tell me, guys. Tell me the answer. I know you can tell me the answer. Oh, Joe had already solved this question today morning. Joe can tell me the answer. Hmm. Shri Balaji, you can find the notes at you can find the notes on the Telegram link. Okay, I'm sharing the notes there. Don't worry. In the meantime, guys, everybody else, give me the answer. Give me the answer. I know you can do it. I know you can do it. La 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 la. Any answers? No answers? Okay. First of all, how to solve this? In this case, I need to know where the image is. So I need to know the other two things. Where will be the object? What will be the radius of curvature? And for that, you need to know the sign conventions, guys. Surender, very good, very good. Surender always giving the first answer. Okay, very good, Surender. Sri Balaji, very good. Okay, so how will you calculate U and R? First of all, see that the incident ray is going to go from here to here. So basically, this direction is positive. So your image object distance will be negative 30 and your radius of curvature, because center will be somewhere here, your radius of curvature will be plus 10. Okay, I hope you guys understood. Hi, Ayushi Kashyap. Okay, so using this, I can write N2 by V minus N1 by U is equal to N2 minus N1 by R. Substitute the values, guys. This will be n2 and n1, nothing is given. I will just assume that it is equal to air. Okay, so I will write 1.5 by v minus 1 by minus 30 is equal to 1.5 minus 1 by 10 is equal to 1.5 minus 1 divided by 10. Okay, now do a little bit of calculation. What you get is 1.5 by v plus 1 by 30 is equal to 0.5 by 10. Okay, now 0.5 by 10, I don't know if you guys know, but that is just equal to 1 by 20. 0.5 by 10 is just equal to 1 by 20. Okay, do I need to solve that, guys? Do I need to tell you how that comes? It just comes. Okay, just believe me, that is what it is. So 1.5 by v is equal to 1 by 20 minus 1 by 30. Now if you do 1 by 20 minus 1 by 30, you know what will that be? That will be 1 by 60. 1.5 by v is equal to 1 by 60, which gives me v is equal to 1.5 into 60, which is 90 centimeters. Okay, so the image will be somewhere here, guys, at a distance of 90 centimeters. See, this is positive, so it will be in the other direction. Okay, and if you draw the ray diagram in this case, guys, if you draw the ray diagram in this case, what will be the ray diagram? The first ray will go like this, the second ray will go like this will be the center of curvature, and this will be the image. They will meet on the other side of the spherical surface. Okay, I hope everybody understood. What type of an image will this be? This will be a real image. This will be a real image. I hope everybody understood. Okay, now guys, if you have refraction at spherical surface, then here we need to define something called focal length. We need to define something called focal length. Okay, and in order to define focal length, we need to first of all define what a focus is. Okay, we need to define what a focus is. Now you have to remember this, that if I have a mirror like this mirror only has one focus. This mirror only has one focus. But if I have a spherical surface like this, it will have two different focus. It will have two different focuses. One focus will be on this side. It will be called focus 1, and the other focus will be on this side. It will be called focus 2. Okay, and both of them have different definitions. You have to remember the definition. What exactly is focus 1 and what exactly is focus 2? Okay, now what exactly is focus 1 and focus 2? What exactly is focus 1 and focus 2? So see, first of all, let's define focus 1. If I keep an object at focus 1, if I keep an object at focus 1, okay, then in that case, what happens is that all the light rays coming out will go will go parallel after refraction. They will go parallel after refraction. So in this case, if this length is equal to how much? If this length is equal to f1, then how do I calculate the value of f1, guys? How do I calculate the value of f1? By the way, refractive indexes, let's assume, are mu1 and mu2. Okay, so how do I calculate f1, guys? How do I calculate f1? What I will say is that in this case, the object distance is negative f1. Do you see that? The object distance is negative f1. And what is the image distance? What is the image distance? The image distance is equal to plus infinity, because where are all these lines going to meet, guys? So they are going to meet at infinity, because they are parallel to each other. And let's just say radius of curvature is equal to r. So I will substitute all of these. I will write mu2 by infinity minus mu1 by f1, okay, is equal to mu1 by minus f1, sorry, is equal to mu2 minus mu1 upon r is equal to mu2 minus mu1 upon r. If you do the calculations, guys, if you do the calculations, you will see that this becomes 0, okay, and this just becomes mu1 by f1. So I just get mu1 by f1 is equal to mu2 minus mu1 by r, which gives me, after some cross multiplication, this gives me r into mu1 by mu2 minus mu1 is equal to f1. R into mu1 by mu2 minus mu1 is equal to f1. Here mu2 and mu1 are refractive indexes. Okay, remember. So in this case, guys, the focal length is going to be mu1 r upon mu2 minus mu1. This is the focal length for the first focus. This is the focal length for the first focus. Now, how is the second focus defined, guys? How is the second focus defined? In this case, what we have to consider is that rays of light are coming from infinity. The rays of light are coming from infinity. Then after refraction, all of them are going to meet at a point. The point at which they meet is called the second focus. Okay, and let's say in this case, I want to find out the second focal length. How do I find out the second focal length, guys? In this case, very simple. You will say u is equal to minus infinity. Do you understand? And v is equal to plus f2. And r is definitely just equal to r. Substitute this in the formula. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Okay, which gives me mu2 by mu2 by one second, which gives me mu2 by f2 minus mu1 by minus infinity is equal to mu2 minus mu1 by r. This just gives me mu2 by f2 is equal to mu2 minus mu1 by r, which after some cross multiplications I will get r into mu2 upon mu2 minus mu1 is equal to f2. R into mu2 upon mu2 minus mu1 is equal to f2. I hope everybody understood. I really hope everybody understood. If you did, please give me a thumbs up. I hope everybody is still following. If you did, give me a thumbs up. Okay. So this is the second focal length. Guys, remember the first focus is here, the second focus is here. Both of them have different formulas. Okay. Sometimes in the exam, they might ask you direct values. Okay. Sometimes in the exam, they might ask you direct values. Then you have to use these formulas. You have to use these formulas. I hope everybody understood. I hope everybody understood. Okay. Alright, next is, guys, next is transverse magnification. Okay, what exactly is transverse magnification? Basically, I want to know what is height of image divided by height of object. Okay, I want to know what this is. This is, by the way, what is called transverse magnification, and I want to know its value. I want to know its value. Okay, so how do we calculate transverse magnification, guys? How do we calculate transverse magnification? First of all, let's assume I have an object here. Okay, let's assume I have an object here, and when an into refractive indexes, there is center of curvature, and next, let's say this is the image of that object. Thank you, Surinder. Thank you. Okay, let's say this is the image of that object. Then this listen, this will be the object height and this will be the image height, the object height and the image height, and I want to know the relation between the two. How do I calculate the relation between the two? Let's make an incident ray like this coming from the top of the object. Then after refraction at point P, it should go to the bottommost point of the image. Okay, I hope everybody understood. Next, what do you do, guys? Next, what do you do? Let's say this is the angle of incidence and this is the angle of refraction. Okay, I have marked now angle of incidences and angle of refraction. Okay, Phoenix is asking, yeah, Surinder, how do you do numericals so fast? Surinder, I also want to know your secret. But Fab Phoenix, I will tell you one thing. Don't worry about doing it so fast right now, my friend. You are learning for the first time. You don't need to be fast right now. Okay, you're doing it for the second or the third time. There is where you need to be fast. Right now, just try to get it. Okay. Yeah. Alright. Ha. So let's say this is I and R, and let's just say this is A and B. Okay. By the way, this formula that I'm going to give you is only derived for small objects. Okay, it's only derived for small objects. The height of the object is supposed to be very, very small. Otherwise, the formula that we derive is not going to be valid. Okay. Anyways, so what I can say here, guys, what I can say here is first thing, I and R are going to be small angles. I and R are going to be small angles. Why are they going to be small angles? Why are they going to be small angles? Because my objects are small. Object is small, image will be small, so I and R will be small angles. Now, if I and R are small angles, then what I can see is sine I will approximately be equal to tan I. Okay, and sine R will approximately be equal to R will be approximately equal to tan R. Now this becomes relevant in 2 minutes. Okay, pay close attention. What I can do is I can use Snell's law. Now guys, if I use Snell's law, what do I get? If I use Snell's law, I get N1 sine I is equal to N2 sine R. N1 sine I is equal to N2 sine R. Okay, and since I and R are small angles, I can write it as N1 tan I is equal to N2 tan R. N1 tan I is equal to N2 tan R, because these are once again small angles. These are once again small angles. Now, if you start from that point, N1 tan I is equal to N2 tan R. Okay, you can write down the value of tan I and tan R, guys. You can write down the value of tan I and tan R. What is the value of tan I and tan R, by the way? What will be the values? The value of tan I and tan R is going to be, tan I is going to be AO by OP. And tan R is going to be BI by PI. Okay, I hope everybody is still following. I hope everybody is still following. Okay, so based on this, now if I ask you guys very quickly, if I ask you what is the value of object distance, so what you will say, what will be the value of object distance? The value of object distance will be equal to, the value of object distance is equal to negative OP. If I ask you what is the value of image distance, you will say plus PI. If I ask you what is the value of height of image, what you will say negative BI. Why did you say negative BI, sir? Why did you say negative BI? Ari, my friends, that is because that height is below the principal axis. Okay, and height of object will be plus AO. Height of object will be plus AO. I hope everybody understood. Now what I can do is I can just take these signs on the other side. This will be negative U is equal to OP plus V is equal to PI. Negative HI is equal to BI and HO is equal to AO. I hope everybody understood. I hope everybody understood and understood. La 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 la. Okay. Now that you know this, what we will do is we will substitute all these into our primary equation. Okay, nahi nahi nahi, bhag mat. Okay, we will substitute all of this into our primary equation. Tan I can be written as plus HO upon minus U. Tan R can be written as minus HI upon plus V. Okay, I hope you guys understood, and let's then substitute them into our Snell's law. If I substitute them in the Snell's law, guys, if I substitute them in the Snell's law, what will I get? I get N1 into, I will get N1 into HO by minus U is equal to N2 into minus HI upon plus V. Now, if you see, this minus and minus sign will get cancelled out. This minus and minus sign will get cancelled out. Okay. And finally, what will remain? Finally, what will remain is I will do some cross multiplication. Okay. Pay very close attention. HI will stay here only. Okay. HI will stay here only. And what I can write is HI divided by HO is equal to N1V divided by N2U. N1V divided by N2U. Can you guys see that? Can you guys see that? If you can see that, superb, and give me a thumbs up. Give me a thumbs up. Okay, which means that the magnification m, which is height of image upon height of object, is just equal to n1 by n2 into v by u. There is no negative sign here, remember that. Okay, there is no negative sign here. Please remember that. Please remember that. Okay, I hope everybody understood, guys. Everybody understood. Now, guys, before I move forward, I have one more very important announcement to make. If you are a repeater student, if you're a dropper student and you want to complete your syllabus in the next 6 months with India's best faculties, and why am I saying India's best faculties? Because all these guys are India's best faculties. They are from Alan Chandigarh. Okay, they are faculties of Alan Chandigarh. Okay, Chandigarh का spelling, wait one second. Alan Chandigarh. Okay, they have been coaching students for a long period of time, and they are here to teach you. They are here to teach you. If you want to finish your syllabus within the next 6 months from these guys, what you have to do is you have to get the pro subscription. Okay, how do you get the pro subscription? You go to vdnt.in/ytpro. Where is that written? It's not written here, but you can write it here. You go to vdnt.in/ytpro and you use my coupon code AAPPRO. When you do that, you get 20% discount on these prices, guys. You get 20% discount on these prices. Okay, so if you want to enroll and study from India's best faculties, you can do that. All right. Now that we have talked about it, let's go back to our studies. Let's talk about one more question. Now this question seems hard, and it is a little bit hard, but let's talk about this. Okay, first of all, there's something wrong with this diagram, so let me make this diagram proper. Okay, this is air, this is some medium, and once again I have air here. Okay, once again I have air here. So in this case, guys, in this case, what happens is parallel rays are coming like this. Then you have to calculate. You have to, my God, you have to calculate that where will the parallel rays meet after coming out of the sphere. After coming out of the sphere, and you have to draw the appropriate ray diagram. Now, IIT JEE mein, they will never ask you drawing the appropriate ray diagram. But in this question, we have asked why. We have asked why. Because it's important that you can visualize what is happening here. Okay, it's very important that you can visualize what is happening here. So let's try to understand, guys. Let's try to understand how the image is going to be formed. Okay, let's try to understand how the image is going to be formed. Now here we have two different surfaces. Here we have two different surfaces where refraction will occur. First, the light rays will get refracted at this surface. First, the light rays will get refracted at this surface. Let's call this surface 1. Now, for a refraction at surface 1, what you will say is your object distance is negative infinity, because the light rays are coming from infinity parallel to each other. Okay, your image distance is question mark, and your radius of curvature is plus 10. Your radius of curvature is plus 10. I hope everybody understands that for this surface, this will be the pole. For this surface, this will be the pole, and that is what you will consider as origin. Now let's try to find out the value of V. So how do we calculate that? I will write 1.5 by V minus 1 by minus infinity is equal to 1.5 minus 1 by 10. Okay, 1.5 minus 1 by 10. Now that gives me 1.5 by V minus 0, okay, is equal to 0.5 by 10, which gives me V is equal to, plus 30 centimeter. Okay, which gives me V is equal to plus 30 centimeter. I hope you guys understood so far. I hope you guys understood so far. Now, what does this mean, guys? What does this actually mean? Okay, so in order to make sense of this, for a minute, imagine that the second surface of the sphere on the right side, the second surface of the sphere was not there. Okay, just the first surface was there. Okay, so how would the ray diagram have looked if you ignore the second surface for now? We will not be able to ignore it, but if you ignore it for now, what you might have seen was that these two rays, after coming out, meet somewhere here. Okay, after coming out, meet somewhere here, such that this distance is 30 centimeter. 30 centimeter. They would have met here if the second surface was not there. They would have met here if the second surface was not there, guys. I hope everybody understood. But the thing is, oh my god, there is a second surface also there. There is a second surface also there. So what will actually happen? They will come here, okay, they will come in this direction like this, and at the second surface they will undergo refraction again. At the second surface they will undergo refraction again. Now if they hadn't undergone refraction, they would have met at this point, but they do undergo refraction, so they will be bent again. Now this is where you have to pay very close attention. This point here would have been the image if the second surface was not there. That point here would have been the image if the second surface was not there. But because of the second surface, now this point is not the image. This point is what we will call an intermediate image. Intermediate image. Okay, this is basically image formed after refraction at surface 1. Refraction at surface 1. But also now this point only will act as object for refraction at surface 2. Refraction at surface 2. This will act as object for refraction at surface 2. Okay, I hope you guys understand. This is an intermediate image. This is an image for this subject, this surface, but now it will act as an object for this surface. Now it will act as an object for this surface. This is the surface 2 with its own pole. Okay, but what kind of an object will this be? What kind of an object will this be? Are rays of light actually coming out of this point? No. Actually, incident rays are about to meet at this point, but because of the refracting surface, they are not meeting. This is what we call a virtual object. This is what we call a virtual object, guys. Okay, I hope everybody understood. And for this virtual object, what will be the object distance? This distance, if you measure, guys, this total distance will be equal to 20 centimeter. If you see, this distance will be 20 centimeter, and this distance is equal to 30 centimeter. So this distance will be 10 centimeter. Okay, 10 centimeter. Balaji, I will come back to your talk. Give me a minute. Okay, so here what we can say is that for refraction at, I will not use this like for refraction at surface 2, okay, object distance will be plus 10, and for the surface 2 radius of curvature will be minus 10, okay, and for the surface 2 the image distance is question mark. For the surface 2 the image distance is question mark. Okay, now I will use the formula n2 by v minus n1 by u is equal to n2 minus n1 by r. Let's try to use this formula. If I substitute all the values in that, what will I get? If I substitute all of the values, guys, what I will get is 1 by V. Why am I writing 1 by V? Because when refraction is happening at the surface, this will be N2 and this will be N1. This will be N2 and this will be N1. So I will write 1 by V minus 1.5 by plus 10 is equal to 1 minus 1.5 divided by minus 10. 1 minus 1.5 divided by minus 10. I hope everybody is following. Okay. Now, if I do the calculation, this just gives me 1 by V is equal to minus 0.5 by minus 10 plus 1.5 by 10. This gives me 1 by V is equal to 1 by 20 plus 3 by 20. 1 by 20 plus 3 by 20. I hope you can see that 1 by 20 plus 3 by 20. 1.5 by 10 is 3 by 20. Which just gives me very simply, I will just remove all of this. Okay, 1 by V is 4 by 20, which is just 1 by 5. V is equal to plus 5 centimeter. V is equal to plus 5 centimeter. Okay, now what does that mean, guys? What does that exactly mean in terms of where the image will be formed? What does that exactly mean in terms of where the image will be formed? Okay, so what is going to happen essentially is this. Okay, let me remove a few things from here. Okay, what is going to happen essentially is this. These two rays would have met at a distance of 30 centimeter. Okay, but now they will undergo refraction one more time and again bend towards the normal. Again the bend, and now they will meet at a distance of 5 centimeter. Now they will meet at a distance of 5 centimeter. I hope you guys can see this. Now they will meet at a distance of 5 centimeter. Okay, so they will just meet before. Okay, I hope you guys understood. I hope everybody understood. Okay, guys. So I hope you guys understood. That is it for today's class, guys. That is it for today's class. It became very heavy at the end. Okay, and that's it. We'll stop here. We'll continue in the next class. We'll start with lenses. Okay, but before going home, let me give you a homework question. Okay, this is your homework question. Give the answer in comments. Okay, okay. Yes, 30 and 5 is confusing. Okay. See, Shri Balaji, I will try to solve your doubts. Shri Balaji, see, when refraction was happening at the first surface, we thought V is equal to 30. Okay, what that means is that after first refraction, these two rays would have met at a distance of 30 centimeter. 30 centimeter from where? 30 centimeter from this point. Okay, they would have met at a distance of 30 centimeter from this point. But because of refraction here, they will meet now at 5 centimeter from this point. They will meet at 5 centimeter from this point. So essentially they will meet at 25 centimeter from the first point. They will meet at 25 centimeter from the first point. Balaji, do you understand? Fab Phoenix, not these lengthy questions. For NEET, you should focus more on. For NEET, you should focus more on this lenses. Okay, which is the next chapter. This is the next chapter. Okay, guys, this is your homework. Please give me the answer in the comments. And that is it for today. I hope you guys enjoyed the lecture. If you did, then please like, share, and subscribe to our channel. You can share this video among your friends. Okay, and I will see you guys in the next class. In the meantime, if you have any doubts, you can send me those doubts on Telegram. Okay, do you guys know about my Telegram link? My Telegram link is at AADITYAP832. Okay, I have solved your doubts in the past. I will solve them again as well. Okay, all right, guys. Can we simply answer logically by the definition of convex and concave mirror? No, Shri Balaji. You cannot do that here because these are not mirrors, my friend. These are lenses. Okay, things are very complicated here. So these are not mirrors, these are lenses. Okay, all right, guys. So I'll stop here. We'll continue in the next class. Hi, Jasveer. Hi. Okay. Chalo, guys. Bye. 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 See you. See you in the next class.